Hi, everyone. Tonight, I'm going to tell you what it's like to fly through a solar eruption, like for real. So all of my pictures of the sun are real images of the sun. So this is a real image of the sun, and that's the Earth to scale. Luckily, it's not that close. And the movie does a great job of simulating the sun, but I've got the real thing. Okay. So if you were to go out into your backyard with a telescope and look at the sun, this is what you would see. This is the surface of the sun, and you should always use a proper filter, of course. Never look directly at the sun. But this is the surface of the sun. It's called the photosphere. And you'll notice that there are these dark spots on the sun. These are called sunspots. And if your telescope is 4 meters across and on a mountain in Hawaii, you can take pictures that look like this. So this is from the Inouye Solar Telescope on Maui, and it shows some really nice detail of what these sunspots look like. Now, if you go into space, you can see the upper atmosphere of the sun. And the reason for this is that in space, you can see wavelengths of light that don't make it down to the ground. They get absorbed by the atmosphere. So this is a layer of the atmosphere that's called the chromosphere. It's about 50,000 degrees. And that same spot is in the square, and now it's bright instead of dark. As we go up higher in the atmosphere, you can see that it still stays bright until we get into the X-rays. And these regions on top of the sunspots in the corona, now we're in the outer layers of the atmosphere, these are called active regions. So here's a movie of an active region from the X-ray telescope on the Hinode spacecraft. And you can see that it's kind of crackling and bubbling along and moving around a little bit. So active regions, they have strong magnetic fields. That's another thing that we can measure on the sun, is the magnetic field. And these white and black patches on the sun are magnetic fields going in and out of the sun. And that same box is around where the sunspot was, where the active region was. You can see there are these strong fields hanging out there. And here's a movie of some of these fields, and sometimes they can really start to evolve like crazy. They can start to swirl around each other, merge into each other, kind of wind around each other. And sometimes these magnetic fields, when they go crazy like this, the sun erupts. So this is a movie of a series of eruptions that happened on the solar limb, the edge of the sun there, taken by a spacecraft called GOES. If you've heard of GOES, you've heard of it because it's a weather satellite, but it also takes these images of the sun. And one of the first questions people usually ask me when they see a movie like this is, wait a minute, these eruptions hit Earth? Which is this big, right? Remember that. And the answer is they absolutely do hit Earth, yes. So what it's like to fly through a solar eruption, part 1, at Earth. This is an image from NASA from the International Space Station flying over the Earth as it's hit by a solar storm, which causes aurora. So the aurora are caused when these charged particles are coming off the sun in these solar eruptions. They get threaded through the Earth's magnetic field, they come down, they hit the atmosphere, and they cause all these amazing colors. And in the business, we call this space weather. I am not making that up, that's really what it's called. So we have the space weather, and it doesn't just cause aurora, it does other things. Really strong storms can affect power grids. They can affect airline flights that go over the poles. Like if you're going from, say, Boston to Tokyo, you'll go real close to the pole. You might get diverted south if there's a strong solar storm. They're important for monitoring astronaut health and safety, and they can affect satellites and GPS. So we want to know when these things are going to happen. So NOAA, who are the people that bring you the weather forecasts, also bring you space weather forecasts. So there's a place in Boulder called the Space Weather Prediction Center, and they try to forecast this space weather. Okay, but can we get closer to the sun and find out what happens if a solar storm passes while we're really close to the sun? Luckily, we can. NASA's thought of this. And we have a mission called Parker Solar Probe, which is in this crazy elliptical orbit, and it goes all the way in really close to the sun. So this is a movie of orbit 13, and you can see it's got a little heat shield on it, and the heat shield always faces the sun. Kind of gets red in the movie as it gets close to the sun. And at its closest approach in orbit 13, it was about 5 million miles from the sun. This is like if the Earth is at one side of the football field, Parker Solar Probe is on the other 4-yard line, right? Really close. This is a picture of a solar eclipse, which is the only way, or one of the only ways you can see the corona from the ground. And I am putting this up just to show that you have lots of these extended features, that the corona goes out really, really far. And that's where Parker Solar Probe is at its closest approach. So it's going to fly right through those extended features. Side note, total solar eclipse is coming through northern New England, April 8th, 2024. So after you're done here, you should go book a hotel in Burlington, Vermont. This is one of the most amazing experiences you will ever have. I've seen 2 solar eclipses now. I'm going to see this one from Dallas. It's truly one of the most amazing experiences you can have. So highly recommended. Nothing to do with my talk, but it's highly recommended. Okay, so we put an instrument at the CFA. We put an instrument on Parker Solar Probe. And you might imagine if you're going to put an instrument on a spacecraft that's going to go that close to the sun, you better do some testing, right? So how to build a solar simulator. We had to build a solar simulator to test our instrument and make sure it didn't melt when we got close to the sun. So the first thing you do, again, I am not making this up, is you buy a couple of IMAX projectors off of eBay. So the IMAX projectors, right, they're made to project 4 stories onto a 4-story screen, right? So that's a lot of light. So you take all that light, and you focus it down a lot, and you can actually simulate the sun. Okay, so here's our solar simulator in action. Here's a piece of aluminum we put into the solar simulator without cooling it first. Whoops. So yeah, don't make your spacecraft that's going to the sun out of uncooled aluminum. That's bad. Okay, so make sure everything is sufficiently cooled. And our instrument is made out of things like tungsten and sapphire, things that have very high melting points. And we tested it all in the solar simulator before we launched it into space. Okay, so Parker Solar Probe made this orbit, and when it got around to the backside of the sun, something kind of cool happened, which is it erupted. So we had another spacecraft back there called Solar Orbiter, and Solar Orbiter caught the eruption. Solar Orbiter is not as close as Parker Solar Probe, but it does have a camera that's facing towards the sun, so we could see the eruption as it was happening. Now what we think happened, if this is our eruption, it's not, but let's pretend. If this is our eruption, what we think happened is that Parker Solar Probe went right through it. All right? So, our instrument on Parker Solar Probe, it's not a camera. What it is it's an instrument that scoops up the plasma, scoops up those charged particles from the sun, and measures them directly. So it's like sticking a thermometer right into the plasma of the sun. So as this eruption was passing by the spacecraft, we were able to directly measure the temperature and the density of that plasma. And what we find is that plasma is really hot. It's like 10 million degrees. It's even hotter than the corona. And it's really dense. So, these are exciting plots for me, personally. But I know they don't really compare very well to the aurora, what it's like to fly through at Earth. Okay, but that's okay, because luckily, our friends at the Naval Research Labs did put a camera on Parker Solar Probe. And this camera doesn't point right at the sun, it sort of points off to the side. So the idea is, while the satellite is sort of flying around the Earth, and while that heat shield is pointed at the sun, this camera is going to be looking off to the side, and if any eruptions come off the sun, it's going to see them sort of go by, right? So in this movie, I'm going to play it a couple of times, because it's worth watching more than once. You can see the sun is that circular thing on the side. That's going to get bigger and smaller as the spacecraft gets closer and farther away. And then there's some streaky bits in this image. That's dust from the inner heliosphere hitting the camera of this instrument. You'll also see some black and white speckles that sort of look like noise. Those are stars. And as you watch this image, there's so much to watch in this image, but as you watch this movie, you're going to see the stars move by. And at one point towards the end, you can actually see the Milky Way. There's also an eruption in this image, or in this movie. So, here we go. There it goes. And now we're flying through it. And there goes the Milky Way. All right, so I'll play that again, if I can. Oop. Oh, no, I can't. Ta-da, okay. Just so you can watch it again. Milky Way. And flying through the stuff. Okay, so that's really all I had to say. Now you know what it's like to fly through a solar eruption. And I love this movie, so I'm sticking around. So I'll be around after the show if you want to ask me any questions or anything. So thanks very much.